Akash Pravasi, and my partner is Hardi Patel, and we have worked on this project called Decoding of Border Gateway Protocol, and we have been guided through our professor Qazi Faisal, and we have submitted this project to them. And basically, we have made this project in our semester, and let's see what we have done. Okay, so this is our outline of this project. So what we have done here is just give the little information that what we are going through in this project, like introduction, BGP overview, and the design of the project, how we made this project, the project plan, and all this. So next is introduction. So basically, what is the BGP? So the BGP is a de facto standard as an inter-domain routing protocol. So basically, the whole internet relies on the BGP protocol, and what we understand from this is when we want to send a packet from one router to another router, or not just router, like to any information from one network to another network, BGP will decide what will be the fastest and easiest route. So BGP protocol is a very important protocol in case of internet. So it manages how packet get routed from network to network. That's what we have already said. And we can face like many wrong configuration flaws, and we can have a lot of loss, like a financial loss in organization, etc. So what is BGP? We have already gone through. Okay, it is a protocol used to exchange information across the internet, and it is a protocol to deal with a huge network. And the one more advantage of this protocol is it eliminates loop from the routing information, so it becomes very easy to ping from one network to another network. So the basic the reason why we made this project, the statement of problem. So there are many factors that may arise as a problem of this project, like there can be a lot of problem in the configuration, like we may have occur like issues in BGP neighbor not able to inform relation with its peer. Like the other common problem would be BGP routing being not being the routing table, or any other problem like TCP port has been blocked, etc. So the main objective to make this project is to configure BGP between two routers in GNS3 and decode the BGP protocol. So that's what we have done in this project. So here is the model of BGP state machine. So let me just briefly go through this. Okay, so BGP mainly have 6 states. The first one is idle state. So what we are doing here, what will happen in idle state? As soon as we configure the BGP, it will go straight to the idle state. That's the first priority. Or even when we have any kind of error in any of the other stages, like connect, OpenSec, or any other stages, it will go back to the idle state. So that could be two main possibilities. Now TCP has been initiated in this state. Now in connect state, TCP should be received, TCP should be established. If TCP is failed to establish, it will go to the active state. Now here is a very important thing. In active state, it will stay for like 120 seconds, which is connection tryout timer, and it is constant. So in active state, it will stay for 120 seconds, and if TCP has been established, it will go to the open SAN. If TCP is not established, it will go back to the idle state. So that's, and usually we may face many errors in that stage because of like IP reachability, or TCP port has been blocked, or because of firewall, any kind of error. So it will then go to the open state if TCP is established. Now after that, the BGP will wait for open messages. So the open message contains very important information. It will contain information about ES number, the version of BGP, BGP ID, and hold timer. So that's the information contains in open message. Now when we go to the open confirm, so open confirm message is like when we receive the open message, and the information, like the information contained in open message is all correct, Like for example, if we are doing on IPGP, so the AS number should be the same. So if there is no error, it will go to the open confirm state, and then from open confirm it will send the keep alive messages. And so basically keep alive message will receive if there is no any kind of error in whole state system, like everything is going perfect. So basically keep alive message has been sent. So keep alive message is basically like, hey, I'm here, like BGP routers are telling each other like I'm here, and yeah, that's it. So in established stage, which is final stage of BGP state, and that's what we need. So in established stage, basically we are going to receive keep alive message, and we are going to send update messages. Now what is update messages? So update messages contains different information like withdrawn routes. So what is withdrawn routes? So withdrawn routes are like, if we didn't want any kind of routes to our neighbors, we can send the message like, okay, we don't need to go to that route, and we are closing the route. So that's like withdrawn. And we can also have information about path attributes of the BGP. So yeah, so that's all about it. And we actually want our BGP in established stage. So this is our topology, and we can see what we have done here. Our BGPS number is 100, our neighbor are BGPS 200. We have created this interface to 12.0.0/24, and what we are doing here is in configuration we are going to ping from PC1 to PC2, and not only that, we are going to ping every router and all. So we use GNS3, GNS3 VM, and Wireshark. Those three are the software that we have used. This is just information that how we can download the routers on GNS3. We have to download the disk images for the routers. So this is our project plan. That's what we have done. So first we create the topology. We have to assign the IP address to all the routers and computers, and that's all the information about what is the IP addresses and IP address of different fast Ethernet interfaces. So these are the information about when we ping from one PC to another PC, and one router to another router. So here our BGP. So we can write the command show IP protocols, and we can get the different information. Like here we can see the routing protocol is BGP 100. We can see our IP address of our neighbor. We can see the routing information sources. We can see, after doing show TCP brief, we can see the local address, we can see the foreign address, and we can also see the state of the BGP which is established. So we can also see the what are the messages that have been sent. Like we can see the open messages, that how many open messages are there, keep alive messages, and all that. This is again the same thing. So here in Wireshark we can actually go through the whole BGP state machine. So here we can see that number 21, 22, and 23 are TCP. So those were the first two stages, idle and connect stages. So the first one, 21, is TCP stage, idle state, and then we can see the TCP has been established and confirmed in between 22 and 23. Now at 24 we go to the open send stage, and we basically send the open message, and BGP will wait for the open message to receive. So that's 24 and 25. So basically that's open send and open confirm. Now last one is established state, and we can see here that we received and we sent and received the keep alive messages from source and destination. So there are 4 keep alive messages, and then last we have 2 update messages. So that says that our BGP has been established. So that's all about our project. And in conclusion, we have configured eBGP on 2 routers using GNS3, and we can see how 2 different ICP can communicate to each other with the help of BGP. So what we have done in our project is we configured 2 BGPs, and we learn all the states of BGP and what could be the trouble, how we can troubleshoot the any kind of error, and how BGP goes from idle state to established state, and how important is BGP to make the internet working. So that's what we have learned in this project. So yeah, that's it guys, thank you. Now I'm going to let my partner Hardi will give the demo for this project. Thank you.
Hello guys, so in this video I will show you our uh, project, which is configuration of BGP on two routers and decoding the BGP protocols. So as you can see that this is our topology right here. It consists of two routers, two switches and two computers. So we have created for the BGP AS number, which is the asynchronous system number, for R1 is 100 and for R2 is 200. We have assigned various IP address to R1 and R2 on FA 0 by 0 and 0 by 1, as well as to the computers. Now first of all we will check if our BGP is working or not. So in order for that I will show you some of the main features. Here I can show you IP route BGP. So as you can see that this is our BGP route just specifically, and then I will show you our neighbor. Yes, so as you can see, we can see our neighbor, which is 12.0.0.2, and the AS number is 200 for it. The BGP version is 4, remote router ID is 192.168.2.1, which is of the PC1, which is the gateway for the PC1. And now I will show you if our connection for BGP is up or not. So in the state if it comes as established, you can know that our BGP state has been established and the BGP has been configured between the routers R1 and R2. You can also see in the BGP summary that it says that total of 420 bytes are been received, and this number of bytes are been sent. So now as you can see that the state in the BGP, it says that it has been established. So we can conclude that the BGP has been configured between the two routers. Now we will try to ping router 1 from router 2. We will ping from computer 2 to router 1. Now as you can see that it is successfully able to ping it. Now we will ping it to router 2, and it is able to do it as well. Here we will try to ping it to computer 1, which is the PC1, and it is able to ping as well. And this would be the same scenario for PC1. It would be able to ping router 1, router 2 and computer 2. So now we can see that it has been successfully established and they are able to ping each other. I will show you how to decode BGP protocols. So BGP protocols, it has 6 stages. As we can see that the BGP has 6 stages: the ideal, connect, active, open send, open confirm and established. Now with the help of Wireshark I will show you all these 6 stages. First of all, we will start when our BGP is trying to get established. So The first stage is the ideal stage. In this stage, it initiates a TCP connection. Now, first of all, the ideal, connect, and active stages, they come under the TCP protocol, and open send, open confirm, and established, they come under the BGP protocol. Firstly, we will see the first TCP protocol, which is the ideal. In the ideal stage, it just tries to connect a TCP, initiate a TCP connection, and if it is successful, it goes to the connect stage, which is again in the TCP. In the TCP, it waits for the TCP connection to be successful. If the TCP connection is successful, it sends a message to it sends an open message to its peers. It sends an open message, but just to its peers, and it doesn't change the state in the connect stage. Now, after it sends a message to its peers, it comes in the active stage. In the active stage, it tries to acquire its peer by initiating another TCP connection. It starts, as you can see, that here it's initiating one TCP connection, and here it's initiating another TCP connection as well. And now, if this is successful, it sends an open message to its peer, as well as after this stage, it can change its state to open send. Now, in open send, we will receive a message known as open message, and it waits for to receive open message from its peer, and verifies other field, and verifies all the field. In open send, it contain the fields contain things such as BGP version, AS number, fold time, and BGP ID. So now, as you can see, in the open message, we are able to locate things such as version, the type of BGP version, AS number, hold time, BGP identifier. Now, if successful, if it sees that all the things are verified and it is successful, it sends keep alive message. It sends the keep alive message, and then it sets it hold and keep alive timers. Now, as you can see, that as it was successful, it sent the keep alive message, and as soon as the keep alive message is sent, the state is confirmed, or the state is changed to open confirm. In this state, the BGP waits to receive keep alive from its peer, and if it gets keep alive, and if it gets keep alive, the state is successful, it is changed to established. Now, I will show you the established state. After the keep alive message, in order to change it to the established, it gives the update message. Now, in this stage, the exchange of updates, notification, keep alive messages takes place with the peers. As you can see, this is an update. We can see the route length, path attribute length. This all shows that our BGP has been configured, and this is all the protocol for the BGP. Thank you.